Welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module that is the web application development. That is the data exchange, that is the syndication, that is known as the syndication, or that is known as the syndication, that is the data exchange, that is also known as the syndication. So let's start with the previous class session what we have covered in the last class, then move to today's topic, that is how the various elements are forms a part of the data exchange. So that is first topic that is considered is the XML, that is extensible markup language, that is considered as a language in which we are using the modifications, in which we are using the languages, in which we are using the scripting language, for example the HTML. So XML is nothing but the we can say the large version or the new version or the extended version of the HTML. So this is considered a language in which the future may replace HTML for coding the web pages. It is as HTML a derived subset of HTML, that is standard generalized markup language, and permits a programmer to define new tags and their meaning for different applications. That means they are used to define the HTML, that is a standard generalized markup language, and permits a programmer to define the new tags. So this is also used for defining the new tags, that is the XML. That is permits a programmer to define new tags and their meaning for the different application, that is known as the XML, that is extensible markup language. And the tags can be defined in a DTD, that is a document type definition, that may also be embedded in an XML file in which it is used, or if the tags used are in the several files. So if there are multiple files, that is used as XML. Then there is a DTD, that is also used in a separate file. So there are three languages that is used in this one, that is the HTML, then there is the HGML, that is standard generalized markup language, and there is the DTD, that is the document type definition, that is also a part of the XML. And in the XML we are also able to create the style sheet that is prepared by the CSS as well as in the XML. And there is a XLL, that is extensible link language, that is a language for defining the hypertext links in HTML or XML web pages, belongs also to the family that is known as the extensible link language, that is a language for defining the hypertext links. Now XML document object is a special data type in the CFMX that is used in the cold fusion markup languages, and there is the XML parse also, that is used as a parse object. And the great advantage of using the XML is that it can be processed by the ordinary CFMX structure function. So it is processed by ordinary, so it is so whenever we are going to use the XML, that is processed by the CFMX, that is a cold fusion markup language or markup extensible. And these must be strictly well formed, and it is well formed if it's free of the syntax error. Then XML is an extensive topic which deserves its own course, so that is known as the XML, that is used for exchanging the data that is based on the XML. And this technology also uses the WDDX, that does not require any extensive knowledge about the XML language. So there is no extensive knowledge that is used for the XML language, that is known as the that is also known as the WDDX. The next is the web distributed data exchange, that is how to distribute the data among the various parts, that is known as the WDDX, that is a web distributed data exchange. So that is an open technology for exchanging all kinds of data by means of the XML representation. So that this is a technology that is known as the WDDX, that is an open technology, that means open to everyone, free for everyone, that is used for exchanging all kinds of data type by means of an XML representation. So whenever we represent the XML, that is represented by the XML representation, that is used to present all kinds of data by means of an XML representation. And it is intended to be used for exchanging data among applications implemented by different software languages and run on different hardware platforms. So that may be run on the different platforms, and that is used for the software languages. And WDDX is constructed on the simple assumption that data to be exchanged is serialized from the local language. There are two parts that is used with the WDDX, that is serialized and the deserialized. And there is exchange that is done between the serialization and the deserialization function that exists for such environment that participating in the exchange. And there is a required function, that is a required WDDX function, that have already been prepared for many programming languages and can be downloaded from the net. So that can be downloaded freely from the net. That is known as a WDDX, that is a web distributed data exchange. And CFMX, that is a that is used with the serialization and the deserialization, that is controlled by the special tag, that is the CFWDDX. Action equals to dash, input equals to dash, output equals to dash. So these are the various tags that is used with the special tags, that is known as the CFWDDX. And the tag can be used without any knowledge of the XML. So we can use the CFWDDX if I am no knowledge of the XML or the XMLs, and also we are going to use this one. Now these are the various categories in which by which we can share the data, by which we can exchange the data among the various art galleries. And whenever there is a loose cooperation, that means whenever we are able to perform the data exchange very easily, that is known as the syndication. So syndication means that is a kind of the loose cooperation, loose exchange of data between the member, between the data, that is known as the loose cooperation, that is known as the data exchange between the art gallery. And the following data about each painting should be included in the exchange. So these are the various data that should be included in the exchange. Now first is identification, the name of the picture, name of the artist, time at which the painting was completed, then estimated value, then picture of the painting. So that means what is the picture, that is identification, then the name of the picture, then the name of the artist, then the time at which the painting was completed, then estimated value, then picture of the painting. That is what is the estimated value of the picture, then what is the picture, that is a soft copy of the picture, that is a picture of the painting. And each gallery has its own database not available on the web. A problem for the data exchange is that the partners have a different platform. Yeah, this is very important point. Whatever the scenario that is used for the data exchange, but the main limitation, but the main concern is that they have a different hardware platforms that is running on the different operating system and the database systems that is running on the different operating system that is running on the different database system. Fortunately, WDDX modules exist for both system environments. Fortunately, they exist on both the system environment, that is WDDX. So this is a figure number 1 that shows the data exchange scenario between the two galleries, that is client 1, client 2, client n plus 1 and plus 2. There is a host A, there is a host B. Now implementation of the exchange, that is how to implement, that is the implementation of the exchange. So to demonstrate the WDDX data exchange, we consider the following templates. So these are the various templates that is used in this one, and I think we have finished with this one, that is index.cfm, formstore.cfm, transmit.cfm, right? And we are going to cover in the today's class, that is a packet.cfm for inspecting a received WDDX packet, that is how to persist with the WDDX package. So these are the various CFM, or we can say the file that is used in this one. That is, first one is the index.cfm, then there is a form store.cfm, then transmit.cfm, then packet.cfm, then table.cfm. And these files are used for generating the menu, for storing and packing, for retrieving and sending, for inspecting, for unpacking and view the received image data. That is a table.cfm. And the menu is quite ordinary and should not include any explanation. That is a index.cfm. That means there is an index that is available. For example, a menu will be generated for this one, and we have to check for the menu, that is what are the various figures that is used in this one. So there is a h2 tag first of all, that is in the main heading. In the blue color, it is available as a menu, that is a menu for the WDDX example. Then there are multiple columns, there are multiple cells that is used in the table, that is a tr, td, then there is an anchor tag that is used, that is stores the picture data in a database, then tr, td, then the transmit.cfm, then the word that is available, that is a transmit data, then the c table, c packet. So that is used with the anchor tag. That means there is a hyperlink on this one. When you click on, for example, C table, so the code that is running in between, that is a table.cfm, that is a C table. Then the table will be closed and the div will be closed. And the form store.cfm initiate the form for uploading a new picture from your client computer to the server of the first gallery, assuming that you are in charge of this gallery and acquired the picture painting. That means, for example, the form store.cfm that is used for uploading a new picture from your client computer of the server of the first gallery, that is used for storing the client computer of the first gallery that is used, that is assuming in charge of this gallery and acquired the picture painting. Then there is a form store.cfm, that is a one part. Then there is a center tag, that is a center tag is used for this one. So this is used for inputting the value. There are multiple picture name, artist, like this is the example that is used for storing the picture data in a database. That is storing the picture data in a database. Then select an image, that is used with this one. Larry, I am just coming within 2 minutes. So this is one of the example, that is storing the picture in a database that we have covered in this one. That is how to store the picture or how to store the data in the database. That is a picture. Then there is a picture created, that is created in this one. Then picture value. So these are the various fields that is used in the table. So there is a storing picture data in a database, that is the h2 tag, that is represented by the h2 tag. Then there is a p, that is available in the paragraph, that is select an image. So this is given image and stored on your PC. It does not matter how you are using the painting, that is available within the p tag. So we are using the p tag for representing the data, right? Then now this is very important point. So the form will be created, that is the action. What is the action? That is a store.cfm. Whenever we use the form store.cfm, that means the store.cfm will be used. Then the method that is available as a post. Then there is a tr.td, that means the row will be used, then the cell will be used. And there is a picture name, that is the name of the picture, the picture artist. Now within one cell there is a picture name. This is one td, this is the opening of this td and the closing of this td. Then this is another td, that is a next td, that is the input type name equals to type name equals to name, then type equals to text, that is a cf input name equals to this one. Then again there is a tr, then td, then picture artist, then td will be opened, then input value, that is artist, then type equals to text. Then picture created, then the next will be used, then the picture value, then the next input type that is used over here, then picture file, that is used as a picture, that is the input name equals to picture, type equals to file. Now these are the type, that is a text, because they are the text boxes, and this is the type, that is a file, because this is the picture file that is created over here. This is the picture file. This is the, we can say, the path or url that is given over here, that is a path from where the file will become, that is a picture file will become. And at last there is a button, that is a submit button is created over here. Then table will be closed and the cf form will be closed. This is the form store.cfm that is used in this one for storing the forms. Then the store.cfm is more interesting. That means this is more interesting, but line number 2 is used for the centered line number 2 is used for the centered uploading tag. This is very important. That is the form number store.cfm, that is the cf file, then action equals to upload, file field equals to form.picture, then destination equals to this one. That means the file, whatever the file that is created over here, that is the path we are giving for the file, that is the cf file. Now there is an action that is available as an action as upload. So what is the action for the cf file? That means uploading the content. Then the file fields, that is the form.picture, then destination, that is session.path, then temp.jpg, then name conflict equals to override, that is the name conflict will be used, that is equals to the override. Then cf file action equals to read binary. So one is the upload, then next action equals to read binary. So first of all upload the file, whatever the url we are giving, whatever the path we are giving, uploading the files. Then action is used as a read binary, and then file session.path, then temp.jpg variable equals to picture, that is used as a variable equals to picture over here. Then cf set picture underscore data, that the struct new, that means the struct new will be used for the picture data, and that is used for the picture content. Then again the same picture data dot name. Now the name will be used, that is known as the, that is stored in the form name. Then the picture underscore data artist, then the form artist, then picture underscore data created, then the form created, then the data estimated value, that is the form estimated value, then picture underscore data picture, that is a picture. Then cf, that is a Core Fusion WDDX, that is a web application development, that is used for the WDDX, that is a WDDX that we have discussed over here, that is a WDDX, that is a web technology, that is distributed data exchange. Then this is done. No, no, where we have done with this one. Now this is CFWDDX. Now next is using the web distributed data exchange, that is action equals to CFML2 WDDX. Then there is the input, that is the picture dot data, then output, that is the picture underscore packet. So one is the picture underscore data, one is the picture underscore packet. Then CF if not is WDDX, that is if it is not WDDX, then the picture underscore packet. Then picture packet is not well formed XML, that is it is not well formed XML, that is also represented within the P tag. Then CF abort, that is the CF abort function will be used, or the abort function will be called, that means aborting the value, that means finishing the value, that means the aborting. Then CF query, the name equals to delete, data source equals to session dot data source. So whatever the session data source, whatever the data source that is available, that is the session dot data source. And there is a query, that is name, that is the CF query name. What is the name? That is the delete. Now delete function or delete query will be used. That is the CF query, delete the function, and what is the data source? So what is the database that is used? That is the session dot data source. Now delete from the WDDX, that is deleting the values from the WDDX. Then CF query, that is a CF query will be closed over here. So one is the starting of the CF query, one is the closing of the CF query. Now the next CF query, that is representing, that have a name, that is a packet in. So the name is given as a packet in, then the data source that is given as a session dot data source. The same data source will be used over here. Now insert into the WDDX, that is insert into the value, that is WDDX, then there is a packet, then values. What are the values that is available over here? Then the picture underscore packet, that is the insert into the WDDX, then values, then picture underscore packet. Then the CF query will be closed over here. So this is the opening of the CF query for inserting the value, this is the closing of the CF query. Then there is a center tag, that is the center tag will be used over here for centering the value. Then CF output, that is the cold fusion output values. Then there is a P tag, that is a paragraph tag, that picture data structure have been successfully stored in the database. So whatever the picture, whatever the data, that is data structure that have been successfully stored in the database, that is also represented with the P tag. Then there is a CF output that is closed over here. So one is the opening of the CF output, one is the closing of the CF output. Then the P tag will be used, that is a paragraph. Then the AHREF, that is the index.cfm, that is the AHREF will be used, that is the index.cfm. Then return, then the A will be closed, that means the hyperlink is available on the return, that is the return to the menu. Line number 10 uses the action equals to this one, that is explained over here, that is used for representing the picture data to the single text string. And this is an XML page that is used to check out the data in the line number 11 to the 13 that is used. Then 11 lines 15 to 17. So these are the various lines that is used for the 15 to 17, that our CF query, that name equals to delete, data source equals to session dot data source to delete the old painting in the database. As we have covered that line 15 to 17, that is used for the delete operation, that is used for deleting the old paintings in the database. And in a real application, these lines would not be included, and lines 18 to 20 store all the painting data representing as a text string in a variable named packet. That is 18 to 20 will be used for storing the value, that is inserting into the WDDX packet. Now what are the various values that is used? That is a picture underscore packet. This demonstrates a compact way of storing the data in the database. And alternatively, the data could of course have been stored in a table with one variable for each painting attribute. That is, the data will be stored in a table that is used as a one variable for each painting attribute, which have been permitted searching in the database by attribute values. That is the database that is used for searching the values, for permitting the searching in the database by the attribute values. And to send a copy of the table to a collaborating gallery, we need to retrieve the packet from the database. So if there is a gallery that is available, that is used to retrieve the packet, that is used to collaborate the or retrieve the packet from the database. And since it is already serialized before it was saved in the database, we may also want to test the packet again for being well formed. So there is a well form that is used for uploading the data, gaining the data, that is used for uploading the content by means of the CF HTTP. There is a CF HTTP that is used for uploading the data into the database. And to avoid working with two servers, we substitute the transfer by a remark tag and continue if we are on the receiving server of the other gallery, that is the CF HTTP tag. And there is a template that is used with the transmit.cfm for sending the data from one gallery to another based on the CFMX. Now remember, we have covered that there are multiple parts for setting the value, that is the index.cfm in the first line, that is implementation. So we have covered with index, we have covered with form store. Now we are going to cover with the transmit.cfm. That is how the transmission, that is how to send and receive the packets of the in the help of the by way of the transmit.cfm. So the template transmit.cfm is used for sending the data, for gathering the data. So that is used for sending the data from one gallery to another based on the CFMX looks like structure. So there is a CFMX that is used with look like structure, that is a transmit.cfm. Then there is a CF query. Now what is a CF query? That is represented over here, that is explained over here. Now name equals to packet out, that means the packet out will be the name that is used over here, and the data source that is used as a session.data source, that means session.data source that is available for setting out the data, that is a session.data source. Then select packet from WDDX, that means selecting the packets or select the packet column name, that is the packet attribute from the WDDX. Then CF query will be open. Now first of all, there is a CF query that is used, that is the name equals to this one, destination data source equals to this one. Then select the packet from the WDDX, then there is a CF query that is available over here. Then CS if not is WDDX. Now if condition will be used for checking if it is not WDDX, then packet out the data. Then there is a P, that is a paragraph tag, that is packet out dot packet is not well formed XML. That means the P tag will be used for storing the data, or a P out dot packet is not a well formed XML. Then CF abort, that means the CF abort function will be used for aborting the values. Then CF if, that is the CF if will be used, that is the closing of the CF if. Now this is the opening of the CF if, that is not in the WDDX, and this is the closing of the CF if. Now this is the code for the transmit.cfm. This is the code for packet transfer to other server. This is within the same server, that is data source equals to session.data source. Now this is the transferring the data to the other server. That is the CF file action equals to write. So that is the action that is given as a write. Then file equals to session.path. Then packet.txt output equals to packet.out.packet. That means the CF file that have action. Now what is the action over here? That is the write action will be available. Now there is a file, that is a hash session.path hash, then packet.txt, then output equals to packet.out.packet, that is used as a packet.out.packet, that is the output. Then there is a center tag in this one. Within the center tag, this is available, that is the h2, then font color equals to 0000ff, then dump of a transmitted packet. That means the h2 tag will be used, that have a font color, that is this one, then dump of a transmitted packet, that is the font will be closed and h2 will be closed. Then the CF output, that is the output coding or tag that is used as a CF out. Then CF dump, that is a CF dump will be used in var equals to double quotes hash packet out. That means the dump is used as a hash packet out, that means the packet out will be used. Then the CF output will be closed. So this is the output that is available of the CF dump, that is a cold fusion dump. Now checking out the variable or setting the variable, that is what is the variable name, that is a packet out. Then the CF output will be closed and the center will be closed. So this is the transmit.cfm. Then this is the CF abort, then p tag, then the CFF will be closed. Then this is the action that is available, then h2, then cf output, then the center tag will be closed. Now lines 2 to 4, that is lines 2 to 4, this is from this one to this one, that is a cf query that have a data source that retrieves the packet, naming the query object packet dot out. So there is an object that is used as a packet dot out, and since a wddx packet is an xml file, so since a wddx packet that is available as a xml file, it is again tested for being well formed. So it is again tested for being well formed, and line number 3 is a substitute for the real transmission. So there is a line number 3 that is also used for the real transmission, that is transferring the packet to the other server. And in a real application, line number 9 must be replaced by the CF HTTP and CF HTTP PAM. That is, the CF HTTP PAM will be used for this one to initiate the transfer to the server of the second gallery, where line number 10 takes care of storing the retrieving packet. That means line number 10 is used for storing the retrieving packet that is used in a text file, that is a packet.txt as the other server. Now, lines 11 to 16 apply the CF dump tag, which displays the complex WDDX packet object by the component. So there is a object packet that is used as a CF dump that is displays the complex WDDX packet object by their components. And figure number 3 illustrates the result that is generated by this tag. And note that this dump is not the packet string representation but an implementation of the packet content. So whatever the packet content that is available, that is not the packet string representation, but that is a representation or interpretation of the packet content. This is the dump of the transmitted packet. This is the figure number 9, that is a packet component. So the packet text string itself can be displayed by the template, that is a packet.cfm. So that is a packet text that is available, that is used as a string itself, that can be displayed by the template, that is a packet.cfm. And this is the packet.cfm that is used over here. So this is the center tag. There is a center tag that is used. Then there is a h2 tag, that is a heading number 2 tag. Then the font color equals to ###0ff. That is the font color, that is the h2 tag, and that is the display of the wddx packet. Then the h2 tag will be closed. Then first of all, there is the opening of the h2 tag, there is a closing of the h2 tag that is available with this one. Then cf file action equals to read. Now the action is available as a read. Then what is the file name? That is a session.path. Then the packet.txt. Then the variable that is used as a packet2. So when is the action that is given, there is a read only file will be created for the cf file. Then the action that is available with this one, the action that is used with this one. Now what is the action that is used? That is a read only file. Then the file equals to hash session.path and packet.txt variable equals to packet2. Then cf output, then text area. Now there is a cf output that is used, and there is a text area, that is a large box will be created, that is a text area. Then rows equals to 15, columns equals to 70, wrap equals to virtual, then packet to text area. That means the text area will be used, that our rows that is a 15, columns have a 70, then the wrap that is used as a virtual. Then packet 2, then there is a text area, that is closing of the text area. Then the cf output will be closed and the center will be closed. This is the packet, that is how the packet will be stored over here. Now this is the packet component that is used for storing the data. So that is the previous part. If I go to the first part, this is the first part, then packet.cfm is used for inspecting a received WDDS packet. That inspecting means if the packet that is received is correct or not. And line 11 to 16, that is used for the dump. This is used for the dumping of the screen, dumping of the message, that is the cf dump variable equals to packet out. And this is itself can be displayed by the template, that is the packet.cfm. Then the center, the next to, then font color, then display of the wddx packet. Then there is a cf file that is used as a read file. Then have a file action that is available with the session.path. Then the cf output. Now what is the output? There is a large text area that is available with the 15 rows and the columns equals to 70. And the XML file for representation of the image that is used in this example is available in figure number 4. And this is figure number 4, that is the display of the WDDX packets. And you can explore the text and the representation that is available in the WDDX. And you can also, for example, see the that the whole image used in this example is represented by the string of the 22,065 characters. And we shall return to the DTD, that is the document type document data for type document, that is used for the WDDX packets in a moment. Now the last part is left over, that is the table.cfm. That is how to create the table for retrieving the messages. So notice that the variable that is representing in the packet are ordered by the value of the variable. So they are ordered by their values. They are ordered by the values of their variable, not by their names. And the whole painting structure is representing in a text string that is a transmitting low number of bytes. That is whole thing is represented by their text string that is surprisingly low number of bytes that is used. And the last template that is used, that is available, that is a template.cfm, that let you see the picture data after it has been serialized. So that will let you see the picture data. What is the picture data that is used? That is used to simulate or deserialize at the simulated receiving end. And when received, the packet was saved in a packet.txt as an XML language. So whenever it is received, so the packet was saved in a packet.txt as an XML file, and this file is read and transformed to a variable, that is the picture underscore data 2 by the line 2. This file is read and transformed to a variable, that is the picture data 2 by the line 2, and deserialized by the line 3 to a structured object. So there is a serialized object, there is a decentralized object that is available, that is the packet data that is used for the line 2 and the line 3. I'm so sorry. And in a real applications, the CFWDDX function in line number 3 must be replaced by the WDD corresponding to the gallery. That is, line number 3 is replaced by the WDDX. Now we have now the structure object. That means we are now going to use the main part, that is structure object, that is the table.cfm. And to display the picture, we must first save the file components or picture components in line number 4, so that it can be binary read in the line number 3. In the remaining lines, the contents of the structure is displayed for the user. For example, table.cfm, that is the table.cfm. Then there is a cf file, that is action equals to read. That means the action file have a action, that is a read action or read operation. Then file have a session.path packet.txt variable equals to packet picture data 2. That means the file that is used as a session path, that means it is our session. The file name is a packet.txt. This is available in the read only mode, and the variable name that is used is the picture data 2. Then cf wddx, then action equals to wddx2 cfml, that is the action that is available is the cfml. Then the input that is used, the input data that is used as the picture data 2, then output equals to deserialized package. That means the output is available as a decentralized package, and there is a cfwddx action, that is the wddx2 cfml. Then cf file action equals to write. So there is an action that is used, that is a cf file action equals to write. Then file equals to hash session dot path hash picture underscore receive dot jpg. So there is a jpg file that is retrieved for the writing purpose. Now we are going to create the table for retrieving the files, that is a cf file. Then there is an action. Now what is the action? That is a write action. So we are we have talked about the operation, and this is the write operation. And the file that is used as a session dot path and the picture received dot jpg. Now the name of the picture is the picture received dot jpg. So now jpg full form. Can anyone, Larry and the Joseph, anyone can tell me the full form of the jpg? Larry or Joseph, anyone can tell the full form of the jpg? you available in the class, Joseph and the Larry? My question is, what is the full form of JPG? Are you able to hear me, Larry and Joseph? Hello. Are you able to hear me? So tell me, Joseph, what is the full form of JPG? Okay. The JPG full form is Joint Photographic Group. In the same way, there is a full form of JPEG, that is the Joint Photographic Expert Group, but this is only JPG, that is the same, that is Joint Photographic Group. Alright? Okay, Larry. So please remember these terms, these are the very important terms. Yes, Joint Photographic Group. Very good, Joseph. So this is the picture dot received, that the JPG file will be received over here. Now this is the input, that is the action is right. Now what is the output? That is what is the output after getting this one? That is the output is a deserialized packet picture. That means the deserialized packet picture will be used. Yeah, Joseph. I will talk to you after the break. Sorry, after the class. Okay. So please concentrate on this one. So there is an output, that is a deserialized, then underscore packet dot picture, then hash, then name conflict equals to override. That means the name conflict that is available for the override, that is the output, that is a decentralized packet dot picture. That means the output is available for by getting the decentralized serialized packet underscore picture. Then name conflict equals to override. So if there is a name conflict, that is equals to the override. Then there is a center tag, then there is a CF output tag. So there is a CF output tag that is used. Then there is a H2. Then there is a H2, that is heading number 2. Then font color equals to blue. So this have a font color, that is a blue. Then this have a received picture data, that is the received picture data, that is the font color, that is the font style. Then the H2 will be closed over here. Then the table tag will be used. Then there is a TR, TD, that is the row. Then there is a cell. In one cell it is available as a name. Another cell it is available as a deserialized packet name. Then in one cell, in the next row there is a one cell, that is the artist, and there is another cell that is known as the deserialized packet dot artist. That means the hash means the value that is available for the deserialized data or deserialized packet dot output or packet dot name, then packet dot artist, then packet dot created. That is used for the deserialize of the data, that is available for the picture packet name or the packet artist and the packet created. Then there is a TR, then value, deserialized, then packet, estimated value hash. That means it is available for the deserialized and the packet estimated value, that is hash. Then P, then image SRC, that is a P tag will be used. Then there is the image img src equals to session.url. So there is a session.url that is used, that is img src, that is session.url. Then picture received.jpg. So there is a session.url and there is a picture received.jpg, that is the image source. Then height equals to 300, width equals to 250. That means the image have a source that have a height equals to 300 and the width that is given as a 250. Then border equals to 0. That means the border is given as a 0. So there's the image source. Now this is the source of the image, from which the image will come, that is the path of the image, that is img src, that is the session.url, then picture received.jpg. So this is the URL, this is the path that is given, that is the picture received.jpg. Then height equals to 300, then width equals to 250, then border equals to 0. So this is the p tag that is used for the paragraph tag. In this, is the image that is available, that is the image received dot jpg. Then the table will be closed over here. So this is the opening of the table, this is the closing of the table. So within a table there are four rows that is used, one and these rows have a two columns or two cells that is available. That is one column contains name, then another column contains deserialized packet name, then artist, then created. Then there is a value that is deserialized data. Then within the p tag it is available as the image src that have a height. So image have a height 300, image have a weight 250. Now, to be able to exchange the pictures, both galleries must have the template discussed above that is supplemented by the CF HTTP tag to send the WWDDX packet to each other. That means to able to exchange the data, both galleries, that is a gallery that is available that have a template that is discussed for supplementing the CF HTTP tag. So there is a CF HTTP tag for supplementing the contents to send the WDDX packets to each other. And the final result from our example for this exchange process is shown in the figure number 5. Now let's see what is the figure number 5. This is the figure number 5. That the final display for the receive data. That is how to display the final data of the receive data. And remember that you must set the session.url also in the application of the example. This is the received packet data. This is the name, then this is the artist, then this is the created, then this is the value. Now DTD for WDDX. What is the DTD? That is the document type definition that is used for the WDDX. Now referring to the introduction of this session, you will wonder that there is a DTD that is used, that is the document type definition that is also used for the WDDX. So there is a DTD that is a document type definition that is used for the WDDX looks. There is a document type definition. So here is a link to the DTD file that defining the language of the WDDX. So there is a link that is used to the DTD file. And there is a linking that is available for the DTD file that defines the language of the WDDX. And if you activate this link, so if there is a link that is activated in the DTD file that is used for defining the language of WDDX, and if you activate this link, the WDDX document type definition is displayed for you. So there is a displayed file that is available, that is a document type definition that is used for displaying for you by means of an XML document object. So that is used for an XML document object, that is a WDDX document type definition. And recall that the use of the WDDX technology does not require that you know anything about neither this DTD, XML or nor XML document object. This does not require that you know anything. That means there is no knowledge that is available for WDDX, that is, there is a prior knowledge of the DTD, XML or not the XML document objects. So whenever we use the DTD in place of the WDDX, there is no prerequisite requirement for the XML, for the compiled file, for the another files, right? Now these are the exercises for this chapter, and that is for the session number 10, that is data exchange, that is syndication. In this chapter we have studied about the various data exchange, that is index.cfm, then the packet store, then transmit, then the packet, then there is a table.cfm. So these are the various parts by which we can send the images by using the identification, name of the picture, copy of the picture, tags of the picture, reference of the picture, that is used for the WDDX, right? So next part, that is your next topic or the next chapter, that is your session number 11, that is your chapter number 11, that is the regular expressions and the CF script. That is what are the various regular expressions and what are the various CF scripts that we are going to continue after the break. So let's take a break, then move to this session, that is the session number 11, that is the regular expressions and the CF scripts. Okay, so let's take a break right now. So come back from the break. Now let's start the session again. So the next session, that is session number 11, that is available symbol, that is in regular expressions in the CF script. That is, what are the various regular expressions that is available, and what are the various CF scripts, that is a cold fusion script, that is used in this one. So let's start with the first topic, that is the regular expressions and the processing. That is how to process the strings, and how to express the, or how to, what are the regular expressions. So regular expressions are a way of specifying the text processing conditions. So if I want to process any conditions, if I want to specify any text processing condition, that is done, or that is done by the regular expression, that are a way of specifying the text processing condition. It is used in a number of programming languages. So there are multiple programming languages by which we can use the regular expression. For example, we have studied about the C and the C++, right? That also uses the regular expression. That also uses the regular expression. For example, we have studied about the keywords, regular expression, string, constant in the C and the C++, if you remember. Right. So it is used in a number of programming languages, but it is unfortunately not standardized. So that means that is not standardized, that is a regular expression, but that is used in various programming languages. It is a very central part of the scripting language, that is a Perl. So this is a very central part of the scripting language, that is known as the Perl. And the regular expression feature in the cold fusion, that is almost compatible with the Perl 5. That is used in the regular expression feature, that is a part of the cold fusion, that is more compatible with the Perl 5. And in the cold fusion, regular expressions are used in two basic ways. So if I'm talking about the cold fusion, the regular expressions are used in the two basic ways. So there are two basic ways that is used in the cold fusion. One is the searching, one is the replacing. That means if I'm talking about the CF script, that is used for scripting the value, that is used for searching and replacing the value, that is searching for the symbol, a pattern in a string of the symbol. So whatever the string that is used, that is available for searching the value, that is available for the symbol patterns in a string of the symbols. So that is a string of the symbol that is used for the symbol patterns in a string of symbols. Then replacing the symbol patterns in a string with new symbol patterns. So one is for the searching the symbol patterns, then next is the replacing the symbol patterns. So one is searching, one is replacing. Searching means search out the symbol pattern that is available in a given string. Then replacing means replaces or pattern in a string with a new symbol patterns. And there are four REs that is used in this one. There are four functions, four regular expressions that is available in the CFMX. Then RE-find, then REGX, then string, start, then return sub expression. So that is the REGEX that will be used, then there is a string, then there is a start function, then there is a return sub expression. So there is a return sub expression that is used for the REGEX, that is a part of the string, that is a part of the start, and there is a part of the return sub expression. That is the RE-find, that is used for the generation, that is used for the string, that is used for the start, regular expression, or the return sub expressions. Then next is the RF find no case. So there is a no case for the RF find, that is the next function, that is the regular expression function. Then REGEX, then there is a string, then there is the start, then there is a return sub expression. So that is used as a return sub expression, that is used for the RE find no case. So one is RE find, then RE find no case, then RE replace, that is a string, then REGEX, then string, then there is a scope. So this is a RE find, then RE find no case, then RE replace, then RE place no case. So these are the four parts, these are the four RE function that is available in CFMX. That is RE find no case, RE replace, RE replace no case. And the first two functions, or the two first functions used for researching or used for the searching, are identical, with the exception that the first is a case sensitive. Now the first two expression that is used, the first two function that is used, that is RE find and the RE find no case, that is a case sensitive, and the second one is the case insensitive. So these are the two parts that is used. One is the RE find, one is the RE find no case. So RE find is used for as a case sensitive. If I'm giving in the small letter, that is different from the capital letters, and find no case is every case is identical, whether they may be a lower case, whether they may be a upper case. And these functions can take up to the four arguments, of which only the two first are the required. So there are four arguments that is available, and out of which only the first two parts are required. And the first argument or first required argument, that is a regular expression that contains a condition for identifying a symbol pattern. So that is used for identifying a symbol pattern, that is used for regular expressions in the text string given as the second required argument. So that is available as a second argument or available as a second regular expressions symbol pattern that is given in the text string that is given as the second required arguments. The first part is the regular expression that contains the conditions for the symbol pattern, and the second part contains the condition for the required argument. Similarly, for the third and the fourth, so first part is RE find, second part is RE no find, RE no case, and the third part and the fourth part that is used for the replacing. So this is first is replacing without taking care of the case. That may be a uppercase, that may be a lower case, that is a RE replace. Then RE place no case, that means the case will not consider. So there is a not case sensitive, either that is used as a lower case, either that is used as a upper case. So similarly, for the third and the fourth function used for the replacing, and these functions have however three required arguments. That is a string to be replaced or to be processed. So this is a string that is to be processed. Then there is a regular rejects, that is a regular expressions identifying symbols, and the new substring to replace identifying string. So there is a new substring, that is a, this is not the sun string, this is missing wrong over here. This is substring, that is a substring is used for replacing the new file that is used in this one. And we have already used the second regular expression, that is a re find no case, and then regax, then string, then start, then return sub expression for passing the text in the agent2.cfm. That is already used for the the second regular expressions that is used, that is re find no case, then regex, then string, then return sub expression for passing the text in the agent2.cfm. The template of the agent2 example in session number 9. We have discussed about the session 2 example, session 9 example, that is the agent2.cfm. And the syntax for forming the regular expressions is based on the set of the operators, character classes, and or portable operating system interface, that is a POSIX classes. So these are the various operators and character classes and the POSIX, that is a portable operating system interface classes. And for a detail, you consult the RPV, that is a RPV chapter that is available in the Code Fusion. So these are the nothing but the theory of the regular expression, that is what are the various regular expressions and how to process the string, that is string processing, right? Now revisiting the search engine. So in session number 6 we studied how to build the search engine by means of the variety of the including the Cold Fusion. We have studied about the parsing, we have studied about these, that is how the text will be created, that is a local or logical diagram for the indexing value. The same we have discussed in last session. So one of the variety function that is used for the indexing, that is index.csm, that is one of the function that is used over here, that explains the content of the function. So that explains the content that is used for explaining the content of these functions. So that is a part of the parsing function, that is part of the identifying and marking the each word of the document for building the frequency list containing each different word appearing in the document. So whatever the word that is appeared, that is appearing for building the word processing, that is appearing in the document. And when parsing of all the documents is completing, so when the parsing is completed, a word frequency list for the whole collection has been generated. So that is generating the whole collection list that is generated for the word processing list. For each recorded word, links have been established to all the documents in which the word occurs. So whatever the word occurs, that is established for all the documents that is being established to all the links in which the word occurs. That is revisiting the search engine. That is done by the parsing, that is used for identifying marking each word of the document. This is a more text, yes, read a text, then read a word, then new word, then end of the file. So these are the various words that is represented by the yes, no, insert, index. So this is a logical diagram for the indexing process. And the result will be an inverted index of words, each with the frequency of occurrences that in the document collection. That is used as the inverted index of the word that is used with the frequency of the occurrences. And the document that is containing the requested words can then easily be localized by means of the index. So whatever the word that is generated by means of the localized index. And based on the each word total frequency in the collection and its local frequency in a document, different kinds of scores of relevance for the individual document can be computed. So whatever the document that can be computed, that is available for the scores of the relevance. And in the following example, we demonstrate how to construct a template and which reads a text file, parses the text by means of the regular expression, and build an inverted word index for the document. So whatever the index document that is represented with the inverted word text file, that is the index that is generated for the regular expressions and build a document. Now this is one of the demonstration that is using the index.cfm, that the application has an introductory form by means of which you can upload your own text file. The second template, that is a parcel.cfm, that uploads, parses and prints the result from the specified file. So whatever the specified file that is used for reading and building the data, that is used for inverting the word, that is used for the document. So we demonstrate how to construct a template which reads a text file, parses the text by means of the regular expression. So this is the introductory, that is the index.cfm file is simple, that is the index.cfm. Then there is a H3, that is heading number 3. Now heading number 3 have a color blue, that is the font color equals to blue. And then text file indexing, so there is a text file indexing that is available within the blue color. Then CF form, that is the CF form will be used. Then action equals to parcel.cfm. So this is the action that is available as a parcel.cfm. Then the method equals to post. So whatever the method that is available, that have a post. The name of the file, then input type equals to file name equals to file name. So that is the name of the file that is given, that is the input type. Now the input have a type, or the type of the file is the file. Then the name is the file name. So whatever the name that is given, that is the file name. Now there is a submit button that is created, that is the input type equals to submit, value equals to submit. So the type is the submit and the value is the submit. That means the button will be created as a submit button. Then the CF form. And the purpose that is available for this template is to permit the user to specify a text file at the client computer for uploading to the server for processing. So whatever the file that is used to specify a text file at the client computer for uploading to the server for the processing. That is used for the template that is used to permit the users to specify a text file. And the next step that is used to search sequentially through the last or through the text string in a file is to identify each separate word. That means to identify the separate words, that is decoded the identified word in a list if not exist already, or increment a frequency counter if exists. That is used to search the sequentially through the text file, that is used for typing the words, that is used for identifying the words, and repeat for the next words. And for each existing word, its frequency counter is incremented by 1. So whatever the each word that is represented, by the index.cfm, and its frequency counter is already or automatically incremented by the 1. And when the document is exhausted, the words are stored in a descending order with the most frequent on the top of the it. So words are stored in the descending order with the most frequent on the top of it. That is the most frequent word that is available on the top of the list. And there is the parser.cfm, that is the line number 2 and 3, the file you have specified in the index.cfm. That is the parcel.cfm. Now this is the explanation of this one, that is used with the MID, that is used with the this one. this I'm going to continue within the next class, that is in the tomorrow class, that is how what is the next step that is used with the parcel.cfm. Now coming to the query, so that's all for today's session. Now coming to the query of the Joseph. Yeah, Joseph, tell me, you have some queries. Yeah, hi Joseph, you have some queries, so please tell me your queries. Yes, tell me Joseph. Pardon? So why you are not submitted the assignment? Can you tell me the reason? So okay, I understand your problem. So what assignments are pending for you? One is procedure programming, one is the e-business, and one is the object oriented. Okay, and you have submitted about the object oriented. No, no, no. I've already given about the object oriented second part also. Just a minute, I will check it. Okay, just a minute. It is confirming. What about Larry? I have given you the assignment. Larry, I have already given you the object oriented assignment or not? Larry.